Check one, check two. Hello, hello, hello. I think we are recording. Hello, welcome. We are live and going here. Hello, welcome. I am Alexander Booth. I am the head program instructor and head facilitator for the IBM Data Science Professional Certification and 10-week bootcamp. This is your week 8 review and week 9 preview video. Crazy that we're already on to week 9, which is actually going to kickstart our capstone week. I think we got 2 weeks of capstone, so we got a few more videos to get through here. But time flies. I was going to say, it feels like just a couple weeks ago that we were learning about Python. I guess it was just a few weeks ago, but I don't know. 10 weeks goes by quickly. As I mentioned, this is our week 8 to week 9 preview review video. So let's get into it. Thanks to everybody that joined the live session earlier in the week. That's already been published and deployed. Let me see. Here it is. Yeah, the week 8 video. Yeah, only 4 days ago. So I was back on Monday. Yeah, thanks to everybody that joined live, and thanks to everybody that watched the recording either backed up in our official Zoom classroom or on YouTube. And hello to the YouTube audience as well here. There's the links. If you're actually signed up for the class, you can see everything in the forums. And of course, just like everything else, I've backed up the week 8 lecture materials in my GitHub. So you'll see under the live session materials, everything we did live during class, and my lecture notes, big ideas, and everything are all down there as well. All right, so with week 8, we continued or finished our machine learning unit and directly built on the foundations from week 7. In week 7, if you remember, we talked about supervised machine learning, or we talked about machine learning as a whole, where it fits with AI and data science. We talked a lot about the different personas you'll run into in predictive learning, ML engineers, AI engineers, MLOps, data scientists, all that good stuff. When we really focused on supervised machine learning, regression versus classification, starting off with linear models, and then what the machine learning framework looks like from data pre-processing all the way through model selection. In week 8, we took that a step further. We moved into advanced algorithms and reiterated realistic machine learning workflows as well as model deployments using Pickle and model serving via APIs and Docker. So yeah, like I said, in week 8, we tackled beyond linear models. We focused on tree algorithms, tree-based models. So what is a decision tree? How do we think of decision trees as conditional splits and branches? How do we then use that to understand how we capture non-linear effects? How do we move beyond decision trees into ensemble models such as random forests, XGBoost, CatBoost, AdaBoost? These are all going to be ensemble trees. We then dove deep into bias, variance, model complexity, model explainability, all that trade-offs, right? As our model gets more complex, it typically becomes harder to explain. And I think increases bias and decreases variance, something like that, or other way around. Decreases bias, but increases variance. We did a quiz question on it. Go back and watch the video. For classification, we talked about complex classification problems, specifically one versus one and one versus rest, for one versus all, for multi-class classification, and how multi-class classification gets evaluated. Other algorithms we talked about support vector machines and k-nearest neighbors. You'll see both of those in typically more exotic situations, but they're also good to compare against your linear models and your tree-based models. Then we moved into unsupervised machine learning. We talked about DB scan and k-means for clustering and demographic analysis, other real-world applications such as customer segmentation. Then we focused on dimensionality reduction, which is going to be, I know it's a long lecture, a lot of stuff covered. The unsupervised stuff we did much more high level though. So we did clustering and then dimensionality reduction. So your principal component analysis and t-SNE. Honestly, you could just have like a long lecture just on that, but mostly we did it just to cover our bases here. Hopefully by the end of week 8, you'll be able to understand all of this stuff, right? Classification, regression, clustering, dimensionality reduction, model selection, and pre-processing, and how all of this fits into the modeling machine learning lifecycle. Then we focused on a recap and a little bit more in depth of how to build a good pipeline, train test splits, data leakage, when we apply scalars, when we apply imputers, why we need pipelines, right, and reliable training and reusable workflows, and then moving into model deployment, monitoring drift, and productionalization of those models. Big idea of the week. Machine learning is not just about training a model, right? We need to be able to deploy it into production and use it to help drive decision making, right? We need to avoid common mistakes like overfitting, data leakage, or misleading evaluation metrics. And we'll learn more about flexibility of production models, but obviously that flexibility makes evaluation and model selection even more important. Let's see. There's some good links here. I think during lecture, I also showed the MLOps link. Let me show that, and then we'll talk about Karen's comments, and then we'll review a notebook, and then move into week 9. So yeah, MLOps is really important to think about. I like the IBM documentation on this. I think they did a good job kind of discussing about it. Again, only 10 years old. Crazy, right? I have t-shirts older than 10 years. Maybe you should have known that, but I was going to say crazy. I have shirts older than MLOps. But yeah, MLOps is something really important, especially as we have more and more machine learning models being deployed into production. Even in the case with AI today, classic ML still has a really strong presence in many enterprises. And MLOps is there to streamline the time and resources it takes to make data science models reach production. But yeah, that was good. Again, there wasn't too much visualizations here, but Fiona, what are we doing, baby girl? Hold on, let me go check on the dog. All right, we're back. I don't think there's too many good visualizations here, but I think that some of the videos are really interesting. And yeah, like I said, this also ties into AI ops or LLM ops. ML, yeah, I think that's the right number of L's. Again, just to make sure that I'm not saying anything crazy, LLM ops now is a new thing off of ML ops, right? So you need to be able to understand all of this as well. This is more for like agentic foundations, right? How do we extend ML ops into like tracking and keeping up with new large language models and agentic AI? But anyway, with ML and AI ops, you have increased efficiency as it automates all the tasks around validation and deployment. Typically, you have improved accuracy and performance as you have that continuous monitoring for drift. Again, we talked about that at the end of the week 8 lecture. Faster time to market, again, being able to deploy new models instantly or even canary test or A/B test multiple models at the same time. Awesome. Awesome. Increases that faster time to market. And then, of course, the scalable development process, right? Being able to deploy these models at scale with governance. So, definitely give this a read if you have time. Watch the videos if you have time. Like I said, I think, here we go. How generative AI affects MLOps. I thought this was really interesting as well, right? So definitely give this a read. Watch the videos if you can. And oh yeah, it looks like you got some explainers on Spotify if you really want to as well. All right. Awesome, awesome. Karen, also again, there's a lot of talk these right now in these last couple of weeks with AI as well. Even though this is a data science boot camp, I think it makes sense to talk AI and AI ops and AI agents. Right? There's a lot of overlap between ML, ML ops, AI, and LLM ops, right? So you'll see that. Um, yeah, how do we like remember things, right? How do we have models that remember, or like whenever see a model that says adding to memory, what does that actually mean? So yeah, I use Pinecone, but also Databricks' native vector store. So this is a really interesting link. I think it does a good job of talking about how at the end of the day, everything's just a database, right? Agentic memory is just stored in a database. It's just stored in a special database called a vector store that is able to be more efficient with text embeddings. So again, depending on how much you know about NLP and all that stuff, right? There's a lot of progressive, I guess, movement that you can pretty much see going from transformers into vector stores into large language models, right? So pretty interesting. I thought that was a good topic here to just to bring up. All right, just to close this out, let me review the main notebook we did in the live session and then hit on the big ideas, and then I'll move over to week 9. All right, so in week 8, the capstone that we did, or the keynote that we did at the end of the lecture, was building a rainfall prediction classifier to predict whether or not it's going to rain tomorrow from data in Australia. I thought it was a pretty good activity. Those some things I would have changed, but a lot of it I thought was pretty solid. So when we read in the data, you'll notice we had almost 150,000 records. We ended up dropping most of those both due to dealing with null values as well as localization. Obviously, Australia is huge, and predicting if it's going to rain tomorrow anywhere in Australia isn't really that, I guess, applicable. So we localized all the way down to Melbourne. So our goal now is to predict if it's going to rain tomorrow in Melbourne. And we have 7,500 observations, which is not a ton, but probably enough for a localized model like this. The features are pretty explainable. We'll do a little bit of feature engineering here, but not too much. Looking at my data, you'll notice we have a lot of strings, right? I think that's mostly it that we need to fix. Maybe we could get some type of seasonality out of the date. That's exactly what we did next. For example, knowing if it's summer versus spring will probably impact the probability that it's going to rain tomorrow. So we fix our date time to the correct data type, and then we do a new feature called season, and then we're able to define our train test splits. From there, we're able to define our numeric features versus our categorical features, right? And so our categorical features, location, wind gust, wind direction at 9, wind direction at 3, rain yesterday, and season, and then our numeric features, which seem to have some good correlations. We then define our pipeline. We're going to apply a scalar to our numeric features just to make sure that our ranges are the same. And then we're going to one hot encode our categorical features. There's not too many distinct categories for all of them, so one hot encoding should be fine. Stick all that into our pipeline. We're going to then try out a random forest classifier with a random state to make it reproducible. We'll add in a hyperparameter grid search, and now we're ready to do both cross-validation and a grid search all at once. The cross-validation basically tries to make sure that we don't get lucky with a train test split. In this case, we're essentially going to have 3 splits. We're going to have a train validation test. You'll notice that we're only going to be running our grid search and cross validation on the training data specifically. So that's just important to understand here. Whenever we do our 5K folds, this will create a validation test or a validation split that we can then use to generate metrics. So again, what we'll do here is that every row is going to be used for both training and evaluation or validation. And then at the end, once we fit our best hyperparameters, we can then run it against the test or the withholding set just to see how it will look like in the real world. So we have 12 options here. 1, 2, 3, 4, 5, 6, 7. Well, we're doing 5 splits, and for 5 folds for 12 candidates, we're doing 60 evaluations. So I'll let this run, and it ran pretty quick, and we ended up with our best parameter here at the bottom. And our best score is 0.85. So let's go see how this does when we run it on the test set. On the test set, looks like there's no overfitting. Our accuracy score is still the same. But one thing to note is that we shouldn't have been evaluating this model on accuracy score. Recall is going to be much more important in this context. If we're trying to predict if it's going to rain tomorrow, and I predict a false negative, I predict it's not going to rain when it does, that makes me look worse than how I actually am. So again, looking at my bottom row, true label 1 means it did actually rain, and we'll see that we're only about 50% right. So if I say it's going to rain tomorrow, it's like a flip of a coin whether or not it does actually rain tomorrow. Cool. Looking at the feature importances, this passes the gut check. All the observations made in the afternoon of today are most important in predicting if it's going to rain tomorrow. Looks like our seasonality feature did not chart here, though, which is one thing to note. All right, so here's how I'd actually do it in the real world. I think I did it down here at the bottom. Oh, we tried another algorithm, right? Oh yeah, we did the logistic regression. The logistic regression ended up with pretty comparable performance. There wasn't too much that actually changed. All right, so here's all actually, I know we did with XGBoost. Oh my God, we're almost to where I actually would do it in the real world. You'll see XGBoost was a little bit better, did improve our recall score. So that's good to know. And looking at the feature importance for the XGBoost model, we'll see that our summer seasonality does become important. And I mean, this can be a negative importance, right? That if it is summer, then it's not going to rain. So pretty cool to see that different algorithms can find different impact from different features. All right, so here's how to actually do it in the real world. In this case, I'm building out a helper function. Basically, it takes in my model and my data, and then what it's going to do is build out that full pipeline. Again, typically in your pipeline, you also want to include an imputer to handle null values. I'm imputing with the mean or the mode, depending on if it's numeric or categorical. And then there's typically other metrics that I would look at. So evaluating train versus test to look for overfitting, as well as including the rock curve and the area under curve score. And we can see, notice I'm not doing cross-validation or grid search here. In my personal work, typically I do that as a second step. Once I've narrowed down which algorithm is actually good, then I do a grid search with cross-validation on that algorithm to optimize it, right? But typically that algorithm selection or model selection, just using pretty intelligent defaults, I think can get you most of the way there. All right, so again, looking at my logistic regression here, we'll see that there's no overfitting. The train test is a pretty close. So is the log loss here. That's also a good metric to use for classification problems. And again, I care about a recall, and my recall is not very good. We also see that with the rock curve, our area under curve score is 851. So don't forget that 851 number. Looking at the random forest overfits, right? It has a perfect score on the training set, which is something we should always be hesitant of. But its log loss is actually better than the logistic regression. And the rock score is also slightly better at 0.88. But it's still not a very good model, definitely not in terms of recall. Looking at XGBoost, we still hit that 0.59. It overfits a bit, but it actually overfits a decent amount. But this is the best log loss we've had, the best recall we've had, and the best awk. It's still tied to the random forest, but it's still pretty good here. And then I even showed some of the more exotic models, such as support vector machines, which was okay. A little bit worse than XGBoost though, and KNN, which was not very good, at least in this example. Finally, once we know which model we want, I walked through how we can use the pickle module to save that file to a binary, to save the model to a binary file, which then can be loaded with its requirements in any other downstream virtual machine. So the common productionalization of this is to use a Dockerized container to read in the requirements and the model object, and then deploy that container as an API to a cloud virtual machine, which can then be just requested during any standard data engineering workflow. All right, I know week 8 was kind of heavy. Feel free to skim through the the dimensionality reduction and the unsupervised machine learning, unless you really want to take that extra time. I think the targeted depth for week 8 is going to be the extra models that we talked about, as well as the other evaluation metrics and the model deployment. So, right. Let me go through my big ideas here. Moving beyond linear models, the good and the bad with decision trees, right? They need a lot of data and they're prone to overfitting. That's the only cons. Bias, variance, complexity, explainability trade-offs. Let's see, what else did we do here? Other models, unsupervised learning. dimensionality reduction, evaluation, right? Evaluation is usually more important than the model or the model algorithm. Same with validation. You don't want to fool yourself into something is good when it actually isn't very good. And then avoiding those workflow mistakes, right? And turning your model into a real system. Yeah, I love this one. From models to actual systems. I think that's huge. All right. Oh, still got to do week 9. Let's do our week 9 preview here. Week 9 is going to be our first week of the Capstone project. So this actually is an important week. So let me make sure that I cover the preview correctly for it. All right. I only went through the notebooks like yesterday, so sorry that this is I'm getting myself refamiliarized with a lot of it. So yeah, for module 9, we're going to be first, let's go over our persona, right? Our persona is that we are going to be a data scientist working for Space Y. Our goal is to evaluate, explore, and build a model based on the real launch data from SpaceX to predict the probability of a booster being reused, right? So having a booster land and be able to be used in another launch. So the first thing we're going to be doing in week 9 is our data collection, data wrangling, and exploratory data analysis. We're going to go fetch data from our APIs as well as web scraping. We're then going to save it off to a database, do some queries, do some exploratory data analysis, and do some data cleaning. In week 10, we're going to do the machine learning modeling, create some visualizations, and put everything together into our final slide deck. Yeah, like I said, the workflow for the capstone, collect data, clean the data, explore the data. That's all week 9. Prepare the data for modeling, do the modeling, document everything, and put it into GitHub for grading. We'll talk about that in a second here. Let's see. I got a couple notes on the first on the code. So let me actually pull it up. I think I already have it here. Yeah. So there's not too many notebooks this week. I think we got 2 in week 2 or 3 in 904, and just I think we only have 5 notebooks this week. So definitely spend your time doing going through them. But in module in 9.04, the API notebook, we just found this out when we were running the code this week. The SpaceX, I think it's because of their IPO, but the repo that we were using for the SpaceX API, it is archived. They basically took it down. So yeah, they archived it just a few days ago. And we've been trying to hit the API, and the API is definitely not working. When I tried to request it, yeah, it threw this little SSL handshake failure. And even without the SSL HTTP, I think then this just doesn't work. This just breaks, I think. So yeah, they took down the SpaceX API that we were looking at, which is not affiliated with SpaceX in any way, but I think they still was like an open source thing, but I still think they took it down because of the IPO and stuff. Anyway, this is my opinion. Long story short, the SpaceX API that we're using doesn't work. So this notebook that you try to run in 904 also won't work. So the solution here is just ignore the notebook, run it as much as you can if you want to. I ran it as much as I did, but it's not there. The output file that it creates, this dataset part 1, I've uploaded into the forums, and it's also in my GitHub if you want to download it to look what it looks like. The other 4 notebooks in Module 9 are completely independent of this. They pull static snapshots of the data from our cloud-hosted source. So for example, the web scraping notebooks, they pull from our cloud location as well as Wikipedia, right? So all of these other locations are still up. And same thing with the data wrangling. I ran all the other notebooks earlier this week. Yeah, so for the data wrangling one, you'll see they're going to pull our part 1 CSV from our AWS or cloud storage. but you can also pull it from my GitHub as well if you want. So again, the other four notebooks should run fine, and we're going to come up with a solution for next class or next cohort, I guess, for what to use instead of the SpaceX API. Um, cool. Let's see. Oh, regarding the web scraping as well. So that's our first note. Let me pull up that here. First note here. The API doesn't work. So the guidance is move forward and you will not lose points because this notebook's broken. All right, web scraping. If you make a request to Wikipedia without declaring who you are, Wikipedia ban or blocks you. So we need to include an optional header to basically tell Wikipedia that, hey, we're a legitimate person and we're not a bot and we're going to scrape you for educational use. So you'll see I did that in my notebook. I added it. I actually think that I showed that it didn't work. If I make the request without it, yeah, this is my 403, and it says, hey, don't be a robot. So I added in a header to declare who we were, and it just worked. So yay. So make sure to do that when you're requesting Wikipedia for the web scraping labs. And I think that's it. So yeah, finally for the capstone, the way that we're building this, all the notebooks are going to build off each other for the capstone. So my recommendation is to run all five notebooks in the IBM lab environment that we've been using or in Colab. Download and save those notebooks to your local machine as well as the outputs after they've been run. And then you need to embed those or upload those to GitHub, which we'll review in the week 9 live session on Monday. And then I've also included a slide deck. There's a slide deck template in module 10, but if you look hard enough, you can probably find it in my GitHub. I think I low-key uploaded it from module 9. Oh yeah, there you go. So here's the example PowerPoint. You can download it and look at it on your own. But your goal is to basically take screenshots and images from the executed notebooks, shove them into the slide deck, and call it a day. I think I can actually show you what this looks like. Yeah, so here's what the example slide deck looks like. Do. Yeah, basically you're gonna have like random slides like data collection, scraping, show an example of how you did web scraping, show an example of how the API looks like, right? Show us some data vises, summarize the charts you plotted, and show us some graphs, right? So you're gonna take these from your notebooks and just shove them in. If you're curious about what this looks like, I have some example capstone projects that I've already published in my GitHub. I really liked the one that James did in my last session. He really made it his own. Now, which again, like feel free to do so. You don't have to stick to the templates that we provide, right? Definitely expand upon it on your own. So he did really, really good here, walking through everything. Obviously, don't just rip and replace, but you can definitely look at it if you need examples of things that we did. So yeah, he did a really, really great job. Note that we also expect you to link to your repository somewhere in your deck. I think I go to the bottom. I think he also linked it at the end here. Yeah, like he's just copying in these graphs and adding in his observations and stuff. Really, really great job with this. I know it can be really annoying to copy in all these screenshots. So just take the time to do it and we'll get you a good grade here. I'll give you some details on timing. Oh my God, this is a long video. Yeah, there you go. There's all of his appendix, right? So if I wanted to go look at some of his stuff, I totally could. So besides the slide deck, I think that's all you're gonna submit in the IBM environment. But like I said, it needs to link to your GitHub, and it's highly recommended that you also include just like a short one-pager executive report. So you'll see that he added this definitely longer than a one-pager executive summary and report. So good for him for going above and beyond with it. But this is going to be a little bit more verbose version of your slide deck. It also helps people understand the scope of your project without having to download slides and stuff. So that's my expectation of you. And as we keep scrolling down in the examples here, you'll see my recommendation for GitHub, a very easy one, would just be to have your Module 9 notebooks set up, same thing with Module 10, and then add in your deck and report as needed. So pretty easy. And again, we'll go through the GitHub stuff in class on Monday for the week 9 lecture. Cool. I think that's all I got here. Don't panic if the API doesn't work. Make sure to keep track of all your notebooks. And if you can go pull the deck from week 10 and start working on your deck this week if you want to. And then, yeah, this is Karen's recommendation for how to do stuff in GitHub, and how to upload files as well. So I think that's a good summary. But yeah, like I said, it's up to you. As long as the data's there, then we can grade it. And remember, Karen and I do the grading, so make sure that you meet our standards and recommendations. Okay, I think that's all I got here. Oh, timeline. So I think the last day of class is going to be what? The last lecture is on the 22nd, and technically you're supposed to have the capstone submitted by the 24th. That means I have to have grades in by the 30th. So you have a few extra days there. If you want to submit or get the capstone in, technically I think the 24th is when it's officially due. You may have to ask for an extension. You can just do that through the UI when you submit it. They get auto approved, I think. But as long as you submit it sometime leading up to the weekend of the 27th, I think we're going to be fine. Um, like I said, you could probably even submit it on the 27th and be good to go. I just got to get the final grades in on the 29th or 30th or so, early that next week. So you can probably have through that weekend, the weekend of the 27th, 28th. But the earlier that you submit the capstone, the better it is for us to get all the grades in and everything. So we'll get our grades in by July 1st, which is 1 week after the capstone officially finishes. And then there's another week, I think, where they verify everything. So it could be up to 2 weeks before everything gets pushed back to the official gradebook. So don't worry too much on dates. And again, we'll try and reiterate this in the forums as well. All right, I've been talking for way too long, but week 9 is an important week with the kickoff of the capstone, and week 8 was a pretty heavy content week as well. All right, I think that's all from me. Take care, everybody. Good luck working on your capstone this weekend. Try and get through the first few notebooks before our live session on Monday, and I will see everybody in our next lecture. Thanks for joining. Thanks for watching wherever you are in the world, and I will see you next week. Cheers, everybody.